Hi, I'm Vance, and welcome to Spec Sense. Fractional horsepower motors are a versatile workhorse used in appliances, furnaces, commercial HVAC equipment, and pumps. When sized correctly, most motors can last for decades, but overheating, moisture, and mechanical stress might cause a motor to fail earlier. The motor nameplate is the key for finding a replacement, as it lists the model number and electrical specs of the motor. In some cases, the model number can be used to find an OEM motor or a direct cross-reference. If needed, you can still use the motor specifications to find a proper replacement. First, match the physical specs. This includes the motor diameter, shaft size, and mounting type. Then, match the electrical specs, which includes horsepower, voltage, amps, RPM, rotation, motor type, and capacitor size. Mismatching will reduce motor life and performance, so it's important to find the right replacement. An overloaded motor draws more amps, runs hot, and will be slower. An underloaded motor will also overheat and be highly inefficient. In this episode, we'll take a closer look at each of these specs. First, measure the diameter and length of the motor. Next, note the shaft diameter and length. Smaller motors will generally have a C-frame, a 3.3-inch frame, or a 4.4-inch frame. Motors larger than 5 inches in diameter will use the standard frame sizes 42, 48, and 56. Now check the mounting type. This could be a rigid base, belly band, or stud mount. Belt drive motors will use a rigid base. On the other hand, direct drive motors will likely use a belly band. Now that you've narrowed down a motor of the same physical size, it's time to match the electrical specs. The motor horsepower refers to how much work the motor can produce at its rated voltage and speed. For example, furnace blower motors are generally 1/8 horsepower or more. Small utility fans are around 1/15 horsepower or less. Next, note the voltage rating. This is the optimal performing voltage of the motor with a 10% tolerance for fluctuations. Dual voltage motors, such as those rated for both 115 and 230 volts, can be wired and operated at either voltage. The current rating, or full load amps, describes the current draw when the motor is operating at its full load. The current will be different based on the horsepower, motor type, and overall efficiency. Keep in mind that not all motors of the same horsepower will function the same, so it's still best to try to match both the horsepower and amperage. Next, look at the motor speed and the number of speeds. Synchronous motor speed is the speed of the rotating magnetic field and is determined by the number of poles. The rated motor speed will be lower than the synchronous speed. For example, a 4-pole 1800 RPM motor will likely have a rated speed of around 1700, and a 6-pole 1200 RPM motor will be around 1100. And this is because all induction motors slip a little when under full load. Slip is basically a magnetic field offset between the windings and rotor that causes the motor shaft to rotate and generate torque. Torque increases as slip increases. To further decrease the speed, some motors will use several wire taps, each with more resistance, which increases the amount of slip. These are multi-speed motors and will often have multiple speeds and amp ratings listed. If there's only one speed and one amp rating listed, then it will be for the highest speed. The direction of rotation is usually written as a code. The code describes whether the motor rotates clockwise or counterclockwise, defined from either the shaft end or from the lead end. Now these are opposites, so clockwise lead end is equivalent to counterclockwise shaft end. Now keep in mind, some motors are reversible, and we'll have a diagram on the nameplate showing how to wire for each direction. PSC and shaded pole motors are the most common motor type used in HVAC applications. A PSC motor can be used to replace a shaded pole motor, but not the other way around. For the same horsepower, RPM, and speed, shaded pole motors will draw twice the amps, since they are half as efficient as a PSC motor. Therefore, using a shaded pole motor to replace a PSC motor is not recommended. These motors will draw more amps and might cause the breaker to trip. When replacing a defective motor, it's also recommended to replace the capacitor. Capacitors are an energy storage device that provide the proper magnetic phase angle and torque needed for rotation. This will either be a start capacitor in a capacitor start motor or a run capacitor in a PSC motor. The capacitance, expressed in microfarads, is a rating of how much energy that can be stored in the capacitor. This should be matched exactly. The voltage rating refers to the maximum voltage that the capacitor can be exposed to. You can use a capacitor with an equal or higher voltage rating, but never with a lower rating, as this can result in capacitor failure. Dual run capacitors are used to support two electric motors, like in air conditioners that use both a compressor and blower fan. They will have 2 microfarad ratings. The higher rating is usually for the compressor, and the lower rating is for the fan. Another important factor is to consider the enclosure type. This is determined by the motor application. Most HVAC motors will be air-over motors and will use the air it moves to cool the motor as it runs. A lot of these motors are rated for continuous duty. Larger motors are designed to be cooled by more airflow, so putting a large motor in a low airflow system will cause heating issues. Air-over motors come in 2 variations. Open air-over motors have a vented housing and are used in clean, dry areas, like in furnace blowers. Totally enclosed air-over motors are used in outdoor or harsh environments, like in air conditioner condensers. Open drip-proof motors have vents on the bottom of the housing for passive cooling and will offer some protection from dripping water. Totally enclosed, non-ventilated motors are used in dusty areas and are cooled passively. Hopefully, this video has given you a better understanding of motors and how to find a replacement. If you like this and want to see more tutorials and informational videos, then subscribe to our channel. And if you need help, you can call or visit an AIMRE location to talk with our knowledgeable staff. Thanks for watching.